Sorry about that, my video cut off, but we've got our two solutions, -2, 6, and 6, -2. The next thing we're going to talk about here is solving systems of inequalities, and these can only be solved by graphing because we want to see visually the range of all of the different circles, or not circles rather, but solutions that we could get from graphing this set of inequalities. In order to graph a system of inequalities, you want to graph both of the inequalities on the same axis. So both of these graphs are going to go together on the same axis. We've got to remember our dotted versus solid lines for inequalities and our shading rules for inequalities. So what we're going to do is we're just going to get right into this. We've got x squared plus y squared is greater than or equal to 16. That's the equation of a circle. And it's the equation of a circle with a center at 0, 0, because we're not adding or subtracting anything, and a radius of the square root of 16, or 4. So what I'm going to do is I'm going to come over here and I'm going to say, all right, my center is at 0, 0. My radius is 4. So an easy way to do that is going to be to count 4 in every direction from the 0 point, and then connect these with a circle. And this is something I'm not super good at. We're going to use a solid line here because we have a greater than or equal to. And so we're going to use a solid line. And we've got to think about where on this graph are the points that are greater than this circle. And with a circle, the greater than less than comes down to an outside or inside debate. So outside the circle are the values where x squared plus y squared is greater than 16. So the outside of the circle is the area that we should be shading for this graph, okay, for this top equation in our system. I'm shading really lightly because we have another circle to graph here, and I want to make sure that that's going to be able to be seen. So this circle has a center that's not 0. This is x plus 1 and y minus 1. So that's going to flip those. Our center is going to be at -1, 1, because we have to change, since we know the circle general equation is x minus h and y minus k. So flipping our signs here. And then the radius is going to be the square root of 36, which of course is 6. So to graph this, we'll graph our center first at -1, 1. And our radius is 6. So from this center point, I'm going to count 6 in 4 different directions. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So those are the outside points of our circle. We can connect them with a circle. And again, these are never very good circles, but you get the idea, and that's really all we need. So there we go. There's our circle. And when we ask where do we need to shade this one, we have to see that, oh, this is going to be at less than or equal to 36. And our shading rules for these sort of values mean that less than is going to be inside the circle. So in a circle, less than is shading inside. Remember, I'm shading inside the big circle here. And now when I've shaded in lightly, notice that there's an overlap area. That overlap area is the solution set of your inequality system. So I'm actually going to go in here and color in the overlap area darker so I can see more clearly where my solution set lives. In this whole overlap area right here. This is going to be the solutions of this system of inequalities. All right, so any point that we pick in this region that's double shaded is going to be a solution of both of these inequalities. All right, let's do a couple other examples here. We've got 2x is greater than 8 minus y, and we have y is greater than an absolute value. So we know how to do both of these. This first one is a line. In order to graph it, we want to make it look like y equals, though. We need it to look like y equals mx plus b, or else it's hard to graph. So I'm actually going to do this. I'm going to add y to both sides, and that gives me y plus 2x is greater than 8. Then I'm going to subtract 2x from both sides. There are other ways to do that. I just figured I didn't want to divide by a negative. So y equals, not equals, but y is greater than negative 2x plus 8. All right, so we've got that negative 2x plus 8 to work with. And we're going to go ahead and graph that. My graph doesn't go to 8, but I know that it's right up 1 above 7, so I'll start there. Negative 2 is down 2 over 1, and then we'll do all of those points. And we need to connect them with a dotted line because we have a greater than, so we're going to use a dotted line here. And we have to shade. Greater than is above the line, so I'm going to shade in lightly here above this line. And I'm going to go ahead and focus on the next equation. Y is greater than the absolute value of x minus 4. There's an absolute value function, which is in vertex form. Our vertex here is going to be negative 4, not negative 4, but positive 4, comma 0, because we have to change this. So we'll go to 4, comma 0. We'll put our vertex point. And our slope in this absolute value v shape is going to be 1, a positive 1. So we can go ahead and put in some points for our rest of our v shape. And we check to see whether we're going to use a solid line or a dotted line here. And we're going to use a dotted line. So I'm going to connect these with a dotted line. And after that, we have to check to see where our shading is going to be for this one. So our shading is greater than. We're going to go above the v shape. So everywhere above this v shape, I'm going to go in a different direction so it looks different. Everywhere above this v shape gets shaded. We notice that there's an area now of double shading. It's this area right here. So we can darken in that area to show that this is the solution set. This is where both of the equations will be true. So those spots are going to be the solutions of our system. All right, one more just for kicks here. So we've got x minus 2y is less than 5, and x squared plus y squared is greater than or equal to 40. Again, this first one is a line. It's a linear function, so let's change it into a y equals. We will subtract x from each side. We've got negative 2y is less than negative x plus 5. Let's divide that both sides by negative 2. Y, remember we divide by a negative, we have to switch and flip the inequality sign, so make sure you do that. Y is greater than, we've got positive 1/2 x plus 2.5, or plus 5/2. So to graph that, our absolute value is at 2.5, and we're going to go up 1 and over 2 each time. Up 1 and over 2 each time. So we're going to start here. We're going to go up 1 over 2. And this is just going to end up putting points in the middle of each of those. But that's totally fine. Oh, shoot. I didn't do my division right. This should be minus 2.5. Ignore those dots I just made. We're going to start at negative 2.5. But we're going to do the same thing. Start at negative 2.5, up 1 over 2, up 1 over 2, up 1 over 2. And that is where we're going to connect our line. It's going to be a dotted line, because we have a no equals to sign there. So here we have a less than sign, right? And if we've got this less than sign that we flipped, now we have a greater than sign. So our greater than sign means we're going to go up here, just like that. All right, and then we've got x squared plus y squared is greater than or equal to 40. So that means that we have a circle and it's centered at 0 because we don't have a plus or minus on our x squared or y squared. Greater than or equal to 40. Well, that means that our radius is the square root of 40. And we say, well, what is the square root of 40? Well, we know that the square root of 36 is 6, and the square root of 49 is 7. So we know the square root of 40 is going to be in between 6 and 7. And since we're graphing, we could check to see just as a decimal what that would be. But we can just kind of eyeball it in between 6 and 7 here. And we can say that that's the radius. So we're going to start at 0 and draw out that radius all 4 different directions. Because again, this is a small graph. It doesn't need to be perfect. And then we can draw the circle in between these. And it is a greater than or equal to, so it's a solid circle. This is not a very good circle drawing that I've created here, but I know you'll be better than me at drawing circles, so that's all good. So there's our circle. And then we're going to say, all right, it says greater than or equal to 40. So that's going to be all the things outside of the circle, all the area outside of the circle. So we can go ahead and shade in the areas outside of the circle. And as we do that, we start to notice that there's an area of double shading. So we can go ahead and shade in that area of double shading more. All right, that's going to be this whole outside rim area above the dotted line that we made first. So anything outside of the circle above that dotted line is going to be part of the solution set of this inequality. And there you have it. All right, hopefully your homework is going to work out well for you today. There are some systems of equations to graph, and there are some systems of inequalities to graph. There are also some systems of equations to solve algebraically. So good luck with all of that. Have a good time. If you have any questions, go ahead and let me know. Thank you. Bye.